Thanks very much for this opportunity to CLF Seattle. I'm happy to go back to the CLF spotlight because I've had a couple of years where we started the same CLF in Alberta, Canada. So I'm happy to be back in the CLF waves. Just a quick one slide only, just to give everybody up to date. Most people don't know about Heidelberg Materials. It's a vertically integrated company who has just rebranded, and you might see the brands on the left, the likes of Cadman, which is very local to Seattle. These are all brands that now are under Heidelberg Materials. It hasn't been a merger or acquisition. It was just change of brands. They're the same company now, but under the one sort of flag. I did want to kind of reiterate the fact that Heidelberg Materials is very invested into the targets of emission reduction. And as such, we have been very interested to make sure that these are validated. And we use SBTi as the validation body to make sure that our targets are duly noted and scientifically verified. We are also not only doing the emission reduction, but we're going as far as making sure that our scope 1, scope 2, and scope 3 have also been measured with a base year of 2020. And last but not least is Heidelberg Material really focuses on two key levers to make sure that we're moving the needle, and that's through CCUS, carbon capture, utilization, and storage, and circularity as the main two priorities that we have currently. So a lot of people might have heard about carbon capture, utilization, storage, but to be completely transparent, there is no silver bullet that will get us to net zero concrete. It's a multidimensional approach. It's a combination of many things, and these are just the ones that we're managing. But there is, a couple more that I'll mention. But just to give an example of innovation product and technologies, we have the Portland limestone cements, which are basically reducing the clinker content in cement, which is basically the carbon intensive portion of the cement. So every time we reduce the clinker content in cement, we reduce the carbon footprint. Similarly to when a concrete supplier reduces the cement content in concrete, SAMS has the same effect. So we're working on both technologies to reduce the carbon intensity in cement and in concrete. We're also using alternative fuels, and you'll see that in a couple more slides. Combustion emissions is a big portion of our emission, and we're trying now have a pathway to use 50% of our fuels coming from alternative fuels. We are also emphasizing the circular economy concept. We're looking at cleaning landfills using harvested ash that has been landfilled, and beneficiating to make sure that we are including in our products. Then we also have carbon capture, which is a drastic reduction in industrial scales and ready to be deployed. And we also talk about the natural carbonation. I'm not sure if everyone knows, but concrete has the natural ability to absorb CO2 over time, and we'll talk about that as well. So this carbon capture, utilization, and storage project is the first in North America. It is based out of Edmonton, Alberta, and it will be allowing us to get to a net zero cement without the use of offsets. It will be reducing 1 million tons of CO2 annually, and it'll be the first to generate not only a net zero cement, but we are taking upon ourselves to generate our own electricity based on the fact that Edmonton, Alberta, unfortunately doesn't have the cleanest of electrical grids. We're taking it upon ourselves to actually generate our own electricity and then capture any emissions from it as well. So it's the first project that will be doing both, reducing the emissions on cement and electricity at the same time, and both without the use of offsets. This project will be operational in 2026, late 2026, early 2027. And as of late April of this year, it was announced that the government of Canada is partnering with us to provide some grants for the building of the project. So I will share now my screen to share a video and hope that this is a little more educational that I can go through speaking to the carbon capture project.
What grounds every awe-inspiring building, but is also the foundation of our homes? What takes us to our favorite vacation spots, but is also a part of where we work and play? The answer is concrete, the second most consumed substance in the world after water. Concrete is incredibly strong. It doesn't burn or rust or rot. Used all over the world, concrete is durable, resilient, and sustainable for the long term. It is literally and figuratively a foundation of civilization. However, we as an industry are facing a big challenge: climate change. The worldwide demand for concrete, and therefore its key binding agent, cement, is so enormous that cement production accounts for 8% of global greenhouse gas emissions, or about 3 billion tons of CO2. At Heidelberg Materials in Edmonton, we have been actively finding solutions to reduce our CO2 footprint by maximizing use of efficient transport, upgrading technology, and finding efficiencies at every stage of the process. But now, we are aiming higher by building North America's first carbon-neutral cement plant. To achieve this, we need to address the two main sources of CO2 from making cement. The first source of CO2 is combustion. Cement requires heating limestone, silica, and other materials at extremely high temperatures within a rotary kiln. The fuel burned to heat the material generates about a third of the CO2. The second and primary source of CO2 comes from making the key ingredient, lime. Lime is created by separating CO2 from limestone, a chemical process that cannot be replaced. The CO2 from combustion and from the creation of the lime are mixed together and then vented through the exhaust. Our solution is to apply an innovative technology called carbon capture and storage. CO2 is captured before it is released into the air, then piped to a facility where it is compressed into a fluid. It can then be safely and permanently stored underground. By using carbon capture technology, we can cut the equivalent of emissions from 200,000 cars per year, all without compromising on the high-quality product you have come to rely upon. Our analysis shows that the current carbon footprint for cement manufacturing, from quarry operations, transport of raw material, electricity usage, cement production, and combustion emissions, can be brought down below zero through the use of biomass fuels, biogenic CO2 storage, carbon capture, and combined heat and power. This creates a path towards net zero concrete without using offsets. With our partners worldwide, we can set a new standard for the industry that will ultimately make a global impact. The worldwide demand for concrete is growing rapidly. By taking this first step towards creating net zero concrete, Heidelberg Materials is forging a path towards reducing embodied carbon emissions in the built environment. It means contributing in a massive way to securing our world against irreversible climate change. And it means a foundation we can rely upon well into the future.
Perfect. Thank you. Let me just go back to this mode. I wanted to spend a couple of minutes just on this graph, which really summarizes the effect of this project. This is a graph, although it's there's actual LCA that sits behind it, and there's all these bars represented with real calculations, which have been verified by third parties, including Climate Earth, who is our company that does our EPDs. So in the and this is a projection, obviously, because the plant is not running yet, so we can't call this a verified LCA until it actually is in operation, but it is a projection. So on the left hand, you see a cement emission intensity, and if you go all the way to the right, you have a scale that measures the concrete emission intensity, which is in kilograms of CO2 per cubic meter of concrete. So if we look at the this graph, not only do we show the emissions, but on the bottom here, you can see that we look at identifying the phases which we're in from cradle to gate, but also the scope that we're addressing in each part of the supply chain. So we start from looking at the graph. Anything that blue bars reflect emissions generated, and the green bars reflect emissions reduced. So if you look at, we measured everything from quarry extraction to transportation of raw materials, electricity, and the major two emissions which come from the process and combustion, which you saw in the video. And then we get the benefit of using alternative fuels. In our case, we're have 50% of all our fuels will be using diverted waste that will be avoiding the use of landfills. And that waste will come in ways of also biomass. And at that point, we'll be getting the benefit of the biogenic CO2 storage. In addition to that, we'll be using the benefits of the actual physical carbon capture and storage project, and the benefit of our combined heat and power, which is the ability for us to make our own electricity and be able to reduce the carbon emissions from the grid. So to the point that we can extend our emissions into downstream scope 3 and measure the transportation of the cement to a concrete operation, the footprint of the carbon of the concrete, the aggregates, everything else, and you batch the concrete, the footprint of transporting the ready-mix concrete to a site, the measurement of the emissions that generated from the building construction site as well. And here we partner with Skanska, who was kind enough to provide us some data on jobs that they have been measured on the A5, which is construction site. And all that to also look at introducing the use phase of the building and getting the benefit of natural carbonation, which comes with the benefit of concrete as a whole naturally. So this is the pathway that we are envisioning, and a projection of how we're going to achieve a net zero concrete without using offsets. One of the things that I'd like to leave with is also a lot of people ask, what's the emission reduction really doesn't come until you actually have permanently removed, and that is correct. So this is the slide that speaks to the actual storage. The CO2 will be captured, but it will also be compressed, and that CO2 will be compressed into supercritical, which is more of like a liquid. And that liquid will be injected into a pipeline where it's going to be injected down into a well below three kilometers below the surface into a deep saline aquifer, going through many layers of impermeable cap rock, which prevents the CO2 from migrating to the surface, and also allowing us to get to a brine, and in allowing us to make sure that that is permanently removed. There is a graph here that I like to show, which looks at the percentage of the trapping, the underground CO2 trapping, as it relates to the time frame. And as you can see here, there's many steps, starting with structural and stratigraphic trapping, residual or capillary trapping, solubility trapping, which is the dissolved CO2, all the way to mineral trapping. And obviously it takes many years, in fact, hundreds or even thousands of years to get to the mineral trapping. But in fact, that CO2 will, as time evolves, is the permanency of the CO2 is more secured, to the point that we believe the mineral trapping will actually turn that CO2 back to a mineral. I hope that was educational, and I guess we're going to go into questions now.